Hi everyone, welcome back. Lastly, we continue on this list, and today we will talk about the filter2D, which makes convolution to an image with a custom kernel. Actually, which we seen before, Gaussian also make a convolution, but its kernel is Gaussian kernel. So today we will talk about how to make a convolution with a custom kernel and the function making this in OpenCV site filter2D. And we will talk about the parameters it's taking. So let's quickly starting. First of all, I want to make also custom matrix because of to see more properly what this function actually do. So let's call it as a custom, and when we did this, after this we can simply streaming to this custom image our parameters, which is 1, 2, 5. Let's make it 3 by 3 also. We forgot to express it. 3 times 3, then 6, let's say 7, 8, 1, 3, 3, more this one. And to be able to see this how it's working actually, or to test it, let's make imshow with imshow show it. Also I want to express it with a window normal to see more properly the pixels, and we simply show it. And custom, we can also calling it as a custom, no need to make it input. Of course we're not forgetting wait key. Then starting, as you can see, this is because of float type. We made it float. Why we making it float type? Because the kernel size, kernel parameters we will define later, probably will be in general in float, because it's making multiplications, convolutions, so it will be in the decimal side. Because of that's why we also defining our matrix input also float. But in here in OpenCV visualization, which is making it imshow, cannot show us in here directly in here the pixel parameters, coordinates. So to see that, we should make it convert it to unsigned char. How to do that? Simply let's call it, first of all, define custom 2D. Let's say custom 2, and convert custom to custom 2, and we just writing here which type we wanna as an output, which is 8 unsigned char 1 channel, and we make it this. And now we see our parameters here by respectively 1, 2, 5, 6, 8, 1, and go through. This is like that. So also we should define our kernel. To explain more better, I wanna define this as a 2 by 2 kernel, which is more easy to explain. And just like custom, we are also streaming their parameters to see the results more properly and how the convolution works. Actually, let's define kernel 1, 1, 1, 1. And also I wanna show the kernel. Also I wanna show the filter2D convolution output, which, or let's call it filter2D. And we will show it, of course, in here, kernel and filter2D. After this, I will change also their taking input, I will change them also. First of all, to see the kernel, let's make the same, actually make the same method to convert it to unsigned char. Dot convert to kernel to, like this. Now we should come through to the filter2D part. Actually, what it's doing, taking source, destination, depth, which is the same depth, it should be same depth, not should be, but for now it should be same depth with the source image, and kernel, which the important one, and core. If you, this is also defining the coordinates, which coordinates you wanna change. If you making -1 to -1, which is the default, it will make center, and delta also. If you wanna add error or other things, you should also define this. If you make 0, nothing change. Border type, not important at all. So let's defining our CV filter2D, but before that, let's make the output here, how it will look like. Filter2D, or yeah, filter2D is okay. Let's calling it filter2D. Our source image is custom. Our destination is filter2D. Our depth is same depth, which is -1 is default one. Input array kernel, which we define as kernel, and point is also, I don't want to change, so just make it -1 to -1, which will be make the central. The target is center of the center of the desired area. Now this is our output, but to be see this also, this is also, because if custom is float type, this will be also float type. So let's simply change it to also unsigned char. Let's call it like this. Filter2D convert to filter2D to CV8 dot this. Then just lastly change this. Now looks like everything fine. Let's see the result. Yeah, now I will explain how it really works. And let's take our kernel. In the left side input, in the right side output of filter2D, which is convol. This is convol image, this is input image. So how convolution works actually. And this is the tool we making, this is the kernel we making our convolution. If you think above of this 4 to 4, and it's like this, this, and this, it's just traveling around the kernel size. But as you said, 1, 2, 3, 4, just 4 options. Let's talk about it later. Then 1 times 1, let's make a calculator, use a calculator. 1 times 1 plus 1 times 2 plus 1 times 6 plus 1 times 8, which gives us the result 17. 17 means you just convolve this one with this target 2 times 2 area, and it's give you result 17, which is here. And if you do the same things for this part, which is 1 times 2 plus 1 times 5 plus the other 8, 1 times 8 plus 1 times 1, which gives the result 16, and is also here. Let's make one more time for this part, which is 8, 1, 1, 2. Eight times 1 plus 1 times 1 plus 1 times 1 plus 1 times 2, which gives us 12, which is exactly here. So as you can see, the result of this is 2 by 2, but this is 3 by 3, but the result is 2 by 2, which is in here. So what these are coming from? These edges. Since the convolved result is 2 by 2, but we wanna the same sizes with the input, it's making a manipulation. For example, this is 15, it's just making it's this edge 15, 17, 17, 17, 17, like this, 16, 16. They are just copying these edges with the next pixels. They're just changing this. So because exactly to make the same size with the input image. This is simply how convolution works. Generally, the kernel not like this, of course. They are generally 0. Blah blah blah. They are general decimal numbers, and this is also in float type. So the results also float type. Then they are converting to unsigned char. This is simply like this. As I said to you before, the Gaussian also making a convolution with the not custom but with Gaussian kernel. What is actually Gaussian kernel? Let's make it simplify. Gaussian kernel 3 by 3, if you write like this, and the result is like this. This is 3 by 3 Gaussian kernel, and if you wanna use this, let's take their 1.1 over 16, which is this, and 1 over 8, which is this, and 1 over 4, which is this. These are, we will use this kernel now to make how actually it works with Gaussian. Is giving the same results or not. Simply let's make new window, which is give us the Gaussian. Let's call it Gaussian, and also we can do this Gaussian output and Gaussian 2, and let's calling it, we talked about this in the previous videos. The input is again custom matrix, and the output is Gauss, and size is, which we decided, 3 by 3, and just sigma make it default. This is Gaussian filter. Then also I want to change our kernel according to which is exactly Gaussian kernel. Just I want to make the same with this kernel, Gaussian kernel, and I want to check the outputs. They are same or not. Our filter2 exactly working expectedly or not. I just want to check it. Now I will write this part, Gaussian kernel, in here. So simply starting with 1, 0, this one, then coming this one, then again this one, I make a big mistake. For example, these are will be dot, of course, so sorry about it. Done. Okay. Zero point 0. Yeah, I think done. These are the should be same with this one. I think this one, and it should be same. I think same. Yeah, we made our kernel now. Then it will give us the Gaussian output exactly same because we defined the kernel Gaussian kernel. Let's also show the Gaussian output. Gauss 2, call it Gaussian, and also convert it. Okay, like this, and we did it. Looks like everything fine. Let's see the result. Anything wrong or not? Okay. Now this filter 2D and this different. Why it makes different? I think we did something wrong here. Let's try to understand it first. What's here? As you can see, we forgot this. Let's go on. Now looks normal. Okay. This is our kernel seems like this because it's converting this float data to integers, so it's just making all zero blah 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 decimal numbers becoming in integer 0. So don't mind this now. And this is custom, which is input. This is normally, as we can see, we used Gaussian functions and Gaussian kernel by itself. We didn't define the kernel, it's just defined already in the background in libraries of OpenCV. So this is the output of the kernel, and if you check this is and this Gaussian totally same. This is filter 2D and this is Gaussian kernel, and they are totally same. Why they are same? Because this Gaussian use kernel already defined this kernel, because if we say 3 by 3, it's automatically converting it to this kernel in background, and they're using. And if we define by ourselves this kernel, and it's again making same convolution with the Gaussian blur in here, filter 2D. So as a result, as you can see, our filter 2D is just make a custom kernel, and some other like Gaussian blur and other blur or box filter, they are using some already defined kernels which some people they defined already. And this is like this. Let's see in a real image, which is in this one. Let's try our example in this equation. Now we don't need custom filter. Let's make an image or custom. I don't want to change, just cv im read and copy. I want to read this as a gray channel because I don't wanna deal with the old channels. This is simply like that. I don't need this. I need this, but I wanna define by myself. Or let's make it like this first. Then everything looks fine. Let's try to work it. This is Gaussian kernel like that, custom. I just want to show again, even in this, which I wanna zoom here. Let's take here. As you can see here the pixel coordinates. I wanna choose here. Let's make it here, and taking it to corner, this one. Okay, do same one for this. Let's find the same coordinate. Okay, I found this and this. Okay, take it to corner. Now you can check these two matrix arrays. For example, here they are totally same. If you can check one by one. For example, let's go the upstairs, down, and compare with the right side. As you can see, it's totally same with the right side. I just wanted to verify it again, it's really working well or not. And now I don't want to work with Gaussian. Let's delete Gaussian. This one, okay. I want to just show how the custom design of kernels work in an image, in a real image, how it works. I just want to show it now. 1 0 1 -1 1 -1. Okay. I don't want to show kernel anymore, or let's show it. As you can see, when I multiply it with this one, it's almost showing the nearest of this, and many of the blur areas gone also. In this different kind of kernels, you can get different images. For example, if you don't really want to take an output like this crushed because no details anymore, not here, there is a rule actually. In this kernel, if the summation of these all values if equal to 1, you will not get a weird output. Now the output, as you can see, I mean summation of this 1 1 1 4 and 0, right? If you make this 1 0 1, you will get an not really crushed output. As you can see, it can be seen. Also, I wanna make attention in here. I mean, take your focus to here. In here, as you can see, in the right side, more sharp, and looks little better than the real image. The reason this is this kernel is used generally for sharpening an image, which people generally uses, and that's why the results are little better and details more clear in here. In the some tissues is becoming more better in the right side also. Simply like this, in this video I want to talk how a convolution works via on filter2D, and how you can make your own custom kernel, and also we verified it's really working as expected with the Gaussian by itself with an already designed function, and we verified it also. I showed some I also showed how to create your own matrix. So simple like this, we stopped in this part. We will continue on. Maybe there is no more good things to mention in here. We already mentioned the important ones. Maybe in the next one we will pass on the next modules. Image filtering, maybe almost finishing. I'm not yet decided. Maybe I will talk again some of these if I see something should be mentioned. Yeah, in this video I think I'm ending here. See you in the next videos.